Hi, I'm Kamakshi Musunaru. This is one of the video presentations which belongs to a series of demonstrations that related to a web application which I created just recently for survey data analysis. In my previous videos, I've explained how to import the datasets and do perform descriptive data analysis and also predictive data analysis. In this video, I'm very quickly going to show you how to perform exploratory data analysis by using 4 different statistical techniques, namely discriminant analysis, reliability analysis, factor analysis, and cluster analysis. It's not possible to describe all these techniques within a couple of minutes. However, I strongly suggest you to go through online resources as what is discriminant analysis, reliability analysis, factor analysis, etc., etc., etc. The very first one is going to be the discriminant analysis. By the way, let me tell you, all the exploratory data analysis methods, techniques that are implemented through this web application are factorial methods, which means we are directly or indirectly trying to test or perform analysis on the latent variables through dataset which we imported to the web application. And now when you press the discriminant analysis, it is just like GLM performing on the factors. Here there is a link, you can just click on this link to learn more about the discriminant analysis. By default, you have the same variable listed in all input widgets. I'll keep the discriminant analysis accepts the factor as a dependent variable, the left hand side of the equation, and numerical variables at the right hand side of the equation. The very first select input widget or widget accepts the factor. You need to give the factor in the first input widget, and the rest of the 3. Right now the discriminant analysis only performs linear discriminant analysis given only 3 variables at the right hand side. In future development, I will be able to provide as many variables as possible in this application. Now let me go and choose the numeric variables in these 3 input widgets, and now my equation is such that gender depends on satisfaction plus satisfaction, question number 1 of satisfaction, question number 2 of satisfaction 2, question number 3 of satisfaction. I think I only have the 2. I have only 2. Okay. Imagine that this is just an abstract data set and fictitious which I simulated for this demonstration. Suppose if you have the third question here, satisfaction 3, then it is indirectly it simply means that you are indirectly trying to test simple linear regression between gender versus satisfaction, but whereas here satisfaction is a latent variable through these 3 variables. Now here I have perception 1, so it is not possible for me to say that I am testing, but anyway, given a chance that you have the 3 questions for satisfaction, you can take the 3 questions as they are representing a latent variable satisfaction, which is going to depend on something like that. And now here the right side you have the result, and this is the linear latent dimension for the discriminant analysis, and here I am supposed to have the plot. It is not possible to get the plot for all, but if your equation, sometimes you get the error if it is not possible for, if the data doesn't support the discriminant analysis. It doesn't mean that there is error in the web application. It simply means that the data is not supporting, because this is just a simulator. You will be having real-time data sets. It is possible for you to test your data, that whether it is possible to implement or perform the discriminant analysis. Or let me change right now. Say if you change the data variable, it is possible for you to obtain the. Now if you go through, it is something like generalized linear modeling in SPSS. We have plots for 2 different groups of the gender. Group 1 is female, group 2 is male, and this is the bar diagram with a density curve, and here you have the summary, numerical analysis or output for the These are the prior probabilities of the groups, and these are the group means, and this is the latent dimension and contribution of these variables to that latent dimension. If you observe very carefully, variable 2, this is the second variable, has positive contribution to the latent dimension. Variable 2 and 4, both of them have positive contribution to the latent dimension, and variable 3, which is perception 3, it is negatively contributing. So and you can just try to interpret these values by going through these links, studying more and understanding these numericals. Now going ahead, I will take you to the reliability analysis, which is very important in multivariate analysis, especially as a matter of prerequisite for factor analysis. Now it is possible for you to choose only the metric variables for something went wrong for reliability analysis. Could not find the function alpha. Now you can see reliability analysis requires more than 2 data variables. You can continue to choose the only thing, the right side, you will see the more and more output being ejected by the application. I may not be able to explain each and every statistic, but you can just go through online resources to the beauty of R is that it try to calculate. I implemented the alpha function in psych package, which is developed by the Professor William Revell of the Northwestern University Psychology Department. He has given a beautiful function called alpha, which calculates quite a few measures for internal consistency. You can read the papers online. For time being, we just need this alpha value. This is the Cronbach alpha, which is regarded as one of the you can study more and more about the Cronbach alpha online. The value must be at least 0.7 to say that there exists internal consistency in the data. This is a fictitious data set, so sometimes you even get minus, but in real-time setups, if you really have original data sets, I mean survey based data in your hand, it is always possible to have, if it has internal consistency, the value will be greater than 0.7, something like that. 0.9 is most of the time accepted, which stands for exceptional. Now let me go to the factor analysis. Again, factor analysis needs metric data variables, which means non-categorical, numerical, and measurement variables, measured variables. So here by default, this is a text input we get in the web application. You need to give the number. By default value is 2, which means I wish to see 2 factors in my analysis. There's a lot of information here, and there is a factor graph where you can see and make some sense out of it. It is not possible for me to explain each and everything. This is a Bayesian information criterion, which is useful to compare to make some sense out of the numerical analysis. Here there are p-values, there is RMSR, a fit measure, and there is chi-square statistic for given degrees of freedom, and there are many. These are something like factor loadings. So if you look at the perception one has a positive loading and the value is acceptable, and attrition has a factor loading of 1, which is highly unlikely. And for factor 2, satisfaction 1, 2, perception 1, 2, satisfaction 1, 2, 3, all of them have positive loadings, and attitude 2 also has some positive loading, something like that. And this is the communality, and this is specificity or something like that. There are some. And going ahead, we have the cluster analysis, and here again you can take all of the variables for cluster analysis. I don't know whether they are nans. Okay, I think it is expecting only numerical data variables. Yeah. So after inputting, by default number of clusters is 2 here. You can also change as 3, and you will see the 3 clusters in your diagram. Let me put 2 to make it simple and cognizant. And if the method chosen is show clusters, then the survey respondents are displayed as by the cluster, just like respondent 1 belongs to cluster 1, respondent 2 belongs to cluster 2, something like that. We just have to go back to the data set and find out the properties of that respondent and say, and come back to the cluster analysis and make some sense out of it. And then if you choose to no clusters, then there will be numerical analysis ejected as in the form of an output. You can just go through. I think the solution does not appear to be a good solution, because the amount of variance described by this data, by the model in the data, is only 28.7%. That doesn't seem to be good. Anyway, this is just fictitious data. If you have real data in your hand, you can just test this. This way you can perform the factorial methods. In short, we call them as exploratory data analysis. This is all about the web application, this web application, and I'll be implementing more and more techniques along with their respective methods in the future development. For any questions, doubts, and also my help, you can just write to this mail, and feel free to call me at this number. Thanks for watching this video. If you really like my video, press like button, and stay tuned for the new content. Don't forget to subscribe to my channel. Thank you. Thanks a lot for your time.